Let's look at a weld centerline crack. Here's a weld, typical weld, two plates welded together. These plates had to be 0.625 inches thick. And right in the center line of this weld, there's a crack. And let's look at the signal characteristics. Trouble with that word. But let's look at it. From both sides of the weld, we should be able to equally see it. And also, I'll probably be able to see, walk that signal up this crack, look at the facets, and probably see the tips of it. I'm going to be using a 60-degree probe, 4 megahertz, 10 millimeter diameter, and I set my reference level at 63.8 dB, which is the side drilled hole on my IIW block. So, looking at this weld, let's run the dB. I'm sitting at reference. Let's run the dB up to 6 dB because we always want to add some dB to our reference level. And just like we have seen before, this is our this is a clean section of the weld. And right in here, we're seeing the root geometry. As I pull back, I should see the toe. And yeah, not so much on this one. Let's check on this side. Yeah, a little bit. That's our typical toe geometry. But let's look. Clean. Oh, boom. Look at that. Wow. Look at high amplitude signal. That right there is our centerline crack. Again, let me move parallel to the weld. We'll see where that will drop out. Gone. We're back into the defect. Come towards us. And gone. So we can see there's a definite start-stop this thing. And it plots about, right now, we have really good amplitude. Plotting about midway down. We're in our second leg of the 60 degree, and we're seeing about halfway down the volume of the weld. And let's look at the signal. I rotate and we'll see some of those facets. See those facets come in and out like an escalator. Move it around. See that? Cracks are jagged, they have facets, and we can see those facets moving around. So you see that the signal response is very strong from this crack. Now let's look at the centerline crack. Let's run over here and see what we can see on this side of the weld. Again, our geometry of our root and the toe. Let's scan along here. Boom, look at that. Nice strong signal. Plotting midway. Look at that signal. Again, you see basically the same signal from both sides of the weld. Let's rotate it around. Look at the facets. We're plotting right about the center line of the weld. And look at this. You can walk that signal. I'm catching that signal right there. I'm catching that crack in my first leg. Here's my first leg. Where's my root? I'll show you the root. Here's our kind of a normal root signal right here. That little guy right there. But let me slide on over right on the toe of the weld. Boom. Look at that. So I'm catching this crack. I can even catch it on my first leg with a 60 degree. Looking at the volume, the body of this weld, and look at that signal. How when I rotate, and it's a pretty long crack going through the center of the weld. As you can see, I'm walking my sound beam up and down that crack. Very high amplitude. Let's run our gain down to reference level. And still have a pretty good response. Let's go over and look at our normal geometry. There's a root. Come over here, look at that. But again, running hot, adding dB to our reference level will alert us to any indications that need further examination. And here it is again. I'm right in the center of that crack, the centerline crack, and second leg. And there, look at walking that. Even on my first leg, I can catch parts of that. So it's a real obvious crack. Look at the amplitude sitting right here at our reference level. That is a centerline crack.